In this video, we're going to learn where the coordinates on the unit circle come from. So we're going to start with an equilateral triangle with each side 1 unit. Why 1 unit? Because in a unit circle, that's why it's called a unit circle, because the radius of the circle is 1, right? That's what it means to be a unit circle. So we're going to start with an equilateral triangle where all the sides are 1. And in an equilateral triangle, how do we figure out the interior angles of each of the equilateral triangle? Well, we know that the sum of the interior angles is 180 degrees, and in an equilateral triangle, all the angles are congruent. So if we divide by 3, 180 divided by 3, so that means all of the interior angles of the equilateral triangle are going to have to be 60 degrees. Now, it turns out that these two right triangles here are going to be congruent to each other, right? So if we take a look at the left side here, so these two triangles, actually, let me write this down. H stands for hypotenuse, L stands for leg of the triangle. So these two triangles are congruent by the HL, or the hypotenuse leg postulate. Why is that true? Because the hypotenuse of the triangle here is 1. So I'm going to kind of just do like an X marks the spot, right? So the hypotenuse is 1, and this leg, or side Y, is going to be the exact same leg of the other right triangle, right? They're going to overlap. So the leg of the blue right triangle is going to match the leg of the green right triangle, and the hypotenuse of this right triangle is also 1. So that's why both of these right triangles are going to be congruent to each other. And we know two things. One is that now these two angles are going to be congruent to each other. And the other thing that happens is that this side of the right triangle is going to be congruent to this side of the right triangle. And that is why I have labeled both of those. I just labeled it any arbitrary variable, let's call it X. So one thing at a time here. So we know that these two angles are going to be congruent, and it turns out, since the sum of the angles of the triangle is 180 degrees, right? Since this is 90 here, 90 plus 60, so that means this guy here has to be 30 degrees, right? So this is 90, this is 90 degrees. So that means, again, for the same reason now, this is also going to be 30 degrees. And if you've noticed, we're going to be dealing with a 30, 60, 90 special right triangle. So we'll review that from geometry in a second. Before we do that, let's actually figure out what X, the value of X, is specifically. So how do we do that? Well, if we look at this entire side of the equilateral triangle, which we know to be 1 unit, well, if this piece is X and this piece is X, then the whole thing, right, X plus X, so this has to be X plus X gives me 2X. So how do I solve for X? Well, I know that that side, so I can set 2X equal to, right, that's the same side as 1 unit. They're equal to each other. And if I divide both sides by 2, that means X is 1/2. So I'll go ahead and, right, so we already start to see where 1/2, right, that is one of the coordinates of the unit circle is born from, right? So that's where the 1/2 is. So we have the 1/2, we have the 1. Later we're going to see where the square root of 2 over 2 comes from, and then we're about to figure out where the square root of 3 over 2 comes from. So let's do this. I'm going to take this. I could choose any of the right triangles because they're going to be congruent to each other. But let's see, I'll draw that over here. Right, so this side is X, but we just figured out that's 1/2, right? So I'm going to label this 60 degrees. And right, so that means this guy up here is going to be 30 degrees. So we have a 30, 60, 90 triangle. We know that the hypotenuse is 1. So we're trying to solve for this missing side here, which happens to be the altitude. In that diagram, I've labeled it Y. So I'll keep that consistent. Okay, so we're trying to solve for Y here, and we're going to use 30, 60, 90 special right triangles. So if you ever in geometry thought to yourself, when am I ever going to learn this stuff? Here is one of the ways that we're going to see some repeats here. So across from a 30-degree angle in a 30, 60, 90 special right triangle, it's going to be any random number, right? So in this case, across from the 30, 60, 90 triangle is 1/2, right? So in a 30, 60, 90 triangle, across from the 60-degree angle, it's going to be that number times, you guessed it, the square root of 3. That's just true in every 30, 60, 90 triangle. Whatever is across from the 30-degree angle, if we multiply that by the square root of 3, you're going to get the number across from the 60-degree angle. So in this case, we just figured out what y is. It's 1/2 times the square root of 3. Now let's simplify that, right? Square root of 3 is really over 1. So 1 times the square root of 3 is square root of 3. And then 2 times 1 is 2. Ta-da! That's where the square root of 3 over 2 comes from. And just by the way, across from the 90-degree angle is going to be that number, right? That number that's across from 30 degrees times 2. So 1/2 times 2 is going to always be across from the 90-degree angle. In this case, it's 1/2, but so what's half of 2? 1. So that works out. Okay, so we're starting to see where the square root of 3 over 2 comes from. We see where the 1/2 comes from. So let us take a look at the scenario here. So if we remember, 60 degrees in radians is pi over 3. Right? So if our reference angle is 60 degrees here, right? So if we're on a unit circle, right? The radius is 1. Whoops. Right? The radius is 1. Reference angle is 60 degrees. So because the sum of all interior angles in a triangle have to equal 180 degrees, that means this has to be 30. Okay, so keep in mind up here, so maybe I can do this. This is going to be a kind of little cheat sheet here. Across from the 30-degree angle, right, is 1/2. Across from the 60-degree angle, we saw that that value was square root of 3 over 2. And across from the 90-degree angle was 1. So this is kind of going to be our little cheat sheet here. So when I label this right triangle, right, across from the 60 degree, so this has to be 1/2. Across from the 60 degree was square root of 3 over 2. And across from the 90-degree angle was 1, which we already know. Okay, so since we are on a coordinate system here, the x, so this ordered pair, the x value has to be 1/2, and the y value of the ordered pair is square root of 3 over 2. And we know, we already memorized, that pi over 3 radians, that ordered pair is 1/2 square root of 3 over 2. What happens if you have a 30-degree reference angle, or pi over 6 radians in a unit circle? So we already talked about across from the 30-degree angle is going to be 1/2. We already see that across the 90-degree angle is 1. But where does the 60 degrees come from? Again, this interior angle has to be 60 degrees because all angles, the sum of all angles has to be 180. And across from the 60-degree angle is square root of 3 over 2, right? So now in a coordinate system, the x value here is square root of 3 over 2, and the y value is 1/2. So when we have a 30-degree reference angle, we already know this to be true. So now, what about a 45-degree reference angle, or pi over 4 radians? Hello, there we go. So 45 degrees, pi over 4 radians. So this is not obviously going to be a 30, 60, 90 triangle. So again, if this is 90 degrees, we got 45 degrees, then the missing angle has to also be 45 degrees, because now 45 plus 45 plus 90 gives us 180 degrees. So now we're dealing with a 45, 45, 90 triangle. So this is the other special right triangle that we have. And so if you remember from geometry class, if you, so obviously the side across from each of these congruent angles has to be the same side length, right? So this is actually an isosceles right triangle, but it's going to be any random number. Let's call it, I don't know, let's call it X, right? So that means this has to be X. Right, so I just picked any random number. I could have called it A, I could have called it B, C, whatever. So in a special 45, 45, 90 triangle, the across from the 90-degree angle is going to be that number times the square root of 2. So the only thing I know in this right triangle is the hypotenuse length, right? So this hypotenuse length is 1, but we just talked about across from the 90-degree angle, it's also equal to that number, we'll call it X times the square root of 2. So we have an equation here. So X times the square root of 2 is equal to 1. And if we solve for X, we're going to divide both sides by the square root of 2. So we end up with 1 divided by square root of 2. And it's called rationalizing the denominator. In math, we don't like radicals in the denominator. So how do we get rid of the square root under the in the denominator? What we can do is we can multiply it by 1, because anything times 1 is itself, but we can disguise 1 as the square root of 2 divided by square root of 2, right? Square root of 2 divided by square root of 2 is 1. But why did we disguise it as radical 2 over radical 2? Because now when we multiply, 1 times square root of 2 is square root of 2. And then square root of 2 times square root of 2 is square root of 4. Square root of 4 is 2. So that's where square root of 2 over 2 comes from. So square root of 2 over 2, this is, if you check on your calculator, is the same number as if you did 1 divided by square root of 2. It's exactly the same. You could fact check me. Okay, so we just discovered that these side lengths, right, whatever we labeled was X, so these are going to be square root of 2 over 2, square root of 2 over 2. And so in a coordinate grid system, that means these are going to be the X and Y coordinates. I hope this sheds some light on where the coordinates of the unit circle comes from. And if you're a student who's learning this for the first time, or even a teacher who's teaching this for the first time, you could take a look. I'll leave under the description my website, among other things. This is my Mastering or Introduction to the Unit Circle series. So what we just did was just a snippet of the lesson. This is a discovery packet, among other things, are worksheets and answer keys to everything. So again, I will leave a link in the description below.